hope all are you safe and doing well. So basically today I want to discuss about binary classification using TensorFlow. It's one of the most used classification. So before jump into the detailed coding section, let's discuss about what is binary classification with a cup of coffee. Basically it's very late for me, but I have a schedule to do this. I really want to share these things with all of you. So what is a binary classification? The binary classification is actually a type of classification that performed on two classes. It's simple. From its name we know it's a binary means it's a two, okay, 0 1 kind of thing. So for the practical example, say all of us using emails, so there is a basic filter that it's a spam or it's a non-spam email. So this is kind of an example of binary classification. So for today's exercise I am actually using IMDb movie database where we are trying to predict the movie reviews using binary classifications. So one of the most important thing is that this neural network cannot understand any kind of regular data like list, string. So basically we have to feed the neural network with tensor. So that also I want to share how to convert the data into tensor. So now welcome to the coding section. I am using TensorFlow 2.0 for time saving. I already have this code written. Now the important thing that I really want to share that if you have a GPU and you want to restrict the CPU utilization, so you can do this in this way. So I am using tf.config and restricted the GPUs. In my later model building section I will share that how I do that. So first let run this portion. Yeah, so it showing my GPU. Now I want to download that IMDb data. My volume is 2000. And here I want to validate that what is my total outcome. So the index is starting from 0 to 1999. So the overall volume is 2000. Now the interesting part of this is that if you want to see that what is actually data in this data set, I can show you that to you. It's 0th location. So this is like the data. It's totally a numeric data. Now what this data is actually refer. So that for that you can use word index and IMDb get word index. You will get that words and from there you can easily extract this data. Now the most important thing that previously I also mentioned, that you cannot feed this data or this numeric data list to a neural network. So for that you need to do encoding. Okay, so for this encoding purpose we are actually using one hot encoder and we determine a matrix. Actually we created a matrix with dimension, as I mentioned here, that length of the sequence and the dimension is 10,000. Okay, so it's length of sequence cross dimension matrix, and only those sequence where the sequence are present, so we actually change it to 1. Okay, this is my function which actually taking that sequence and dimension. So basically it's taking only one parameter as an input. Now this function, this np0, is actually creating that matrix with everything, it's every element of that matrix is become 0, and by using for loop and the sequence we are actually adding 1 there. Now this is the operation we are performing on our x train and x test, and this is the one of the output of 0th location. Okay, so similarly we need to vectorize our labels also. So we just converting that labels to the arrays. Okay, now it's a really very important thing. We are now going to build a model. So for this we are actually using that sequential, and we are using dense. Okay, in my previous video I did in detail I discuss about what is sequential and what is dense. Now similar here, that this number 16 under the dense is actually referring that hidden layer. Our activation function is relu. Here I define the small Python code what is actually relu. So if it is 0 input, you are giving it as 0 input, then it's return 1, and or whatever the output is more than greater than 1, and if it is 0 then it's return 0. And here we are using sigmoid. So sigmoid is actually the predicting graph, so it's an exponential function. So this is the sigmoid functions actually. Now we are compiling our model. So for our optimizer I am using RMS prop, and here we are compiling. Now the important thing is that here I am actually restricted the overall process with GPU 0. Okay, so it means if the GPU 0 is available then only it's run. Okay, otherwise it's not going to run. So if I run it, so now if there is a GPU is available then it's running. So somehow I think I need to run the overall code. Yeah, so see that GPU is available now, so that's why it's executing. If there is no GPU then it's not executing. So this dictionary actually contains that 4 entries, 1 per matrix. This was actually monitored during that training process. Now here we actually plotting the training and validation loss. So you can see that from the above graph that for each and every epoch the loss is decrease and training accuracy is increase. So we can easily improve this model. I just added little bit modifications here. So I increase the dense layer, and I added extra sigmoid layer here, and similar it's again the GPU restricted code. So here after running this I will get the accuracy near to 86%. Yeah, here is the epoch size. So previously also I have 20 epoch size, here also I have 20 epoch size. So if you increase the epoch size, it might be case that you will get much better result. If I made it 80 and I will run it, so see that it will might be the case that it will increase the overall accuracy. So this is actually running. So see that the accuracy is, my previous accuracy is gross accuracy is 86%, but here I am getting accuracy 95% more. It it will take time. Okay. Yeah, but more or less somehow there is a drop, so that so now we can see that the overall result is like 86%. So we can easily change the result by also adding some or changing that optimizer. So here I want to mention that what is optimizer. The optimizer, or the goal of the optimizer, is to optimize the predicted value. Okay, so actually what is this actually support the machine learning's view that the purpose of machine learning is reduce the difference between predicted output and the exact real life data. Okay, so this is kind of the same task of the optimizer. So we can easily do that by using atom. And say I can increase the epoch size, or I can increase the batch size. So now I can check that. Yeah, so yeah, so the accuracy is 86%. Kind of perfect 86%. So this is the basic of binary classification. Okay, I already try to share this overall code base to GitHub, so that you all can access it and try yourself. If you like this video, please like and subscribe my channel. I really want to continue try to upload some of the new videos regarding this deep learning. Also I am doing some POC over Kafka, so I hope I can share that also with all of you, so that you have some hands-on basic knowledge over Kafka. Thank you so much for watching. Please like and subscribe.